Good morning everyone. My today topic is single phase half wave AC voltage controller. In previous lecture we discussed what is AC voltage controller. It is the controller which convert fixed AC voltage into the variable AC voltage. So in this lecture single phase half wave AC voltage controller we will discuss circuit diagram, voltage waveform and the output voltage equations. So this is the circuit diagram of single phase half wave AC voltage controller. This is a thyristor, this is diode, this is resistance R and this is input voltage Vm sin omega t. So this is the Vs Vm sin omega t. So let's understand how this circuit will work. For positive cycle of Vs, a positive cycle of source voltage, T1 will conduct, and for negative cycle D1 will conduct. So when T1 is triggered at an angle of alpha, when T1 is triggered means when thyristor gets forward bias for positive cycle, then T1 is triggered at angle alpha, then what happens? It gets turned on and current will flow from here to T1 and resistance again to source voltage. This is the current will flow through T1. So output voltage will be like this, and this is the resistive, this is the output voltage, this is a resistance. So output current will be same as the output voltage I0. For negative, when source voltage is negative, means when source voltage is negative, what happen? This is minus, this is plus, this is minus, this is plus, and what happen? The diode gets turned on. Diodes gets turned on as the voltage gets positive. This diode gets turned on. So in the output, you get the output voltage at is input voltage. Same as whatever in the input voltage, you will get same in the output voltage. And current will be same as the output voltage. Now again. For positive cycle, what happened? For positive cycle, you will not triggering the thyristor T1. You are not triggering thyristor T1. So what happened? Output is 0. You are not triggering the thyristor T1. So output will be 0. D1 cannot be turned on. Only T1 can be turned on. You are not triggering T1. So at theta equal to alpha, you trigger T1 and output voltage again will be like this, and same as at that time when output voltage is 0 and output current is also 0. When output voltage appear, same output current will appear. So this is the output current waveform and that one is the output voltage waveform. Now let's write down the equation for the single phase half wave AC voltage controller. One more thing. For negative cycle, current will flow from here to here like this. So this is for negative cycle and that one is for positive cycle. And now write down the equation. Average output voltage. Average output voltage for single phase half wave AC voltage controller. So equation V naught equal to 1 upon T 0 to T Vm sin omega t d of omega t. This is the conventional equation. With the help of this equation, we find the average output voltage. Now write down what is the time period of this waveform. Time period of this waveform is 2 pi. So equal to 1 upon 2 pi. Integrate 0 to 2 pi Vm sin omega t d of omega t. 1 upon 2 pi. 0 to 2 pi output voltage is 0. 0 to 2 pi output voltage is 0. So integrate alpha to 2 pi Vm sin omega t d of omega t. This is V naught. Now integrate it. V naught equal to 1 upon 2 pi. Take Vm outside. Alpha to 2 pi sin omega t d of omega t. Vm by 2 pi sin omega t, integration of sin omega t minus of cos omega t, and alpha to 2 pi. So V naught equal to Vm by 2 pi cos minus of cos 2 pi and plus cos alpha. Cos 2 pi is 1. So V naught equal to Vm by 2 pi cos alpha minus 1. So this is the average output voltage of single phase half wave AC voltage controller. Now find the average output current. Average output current. Average output current I naught equal to V naught divided by RL. RL is the load resistance. This will be Vm by 2 pi RL cos alpha minus 1. So this is the average output voltage and average output current. Now find the RMS value of output voltage. RMS value of output voltage. RMS value of output voltage, how we will find RMS value of output voltage? VOR square equal to 1 upon 2 pi 0 to 2 pi or alpha to 2 pi Vm square sin square omega t d omega t. Equal to Vm square divided by 2 pi alpha to 2 pi sin square omega t d of omega t. Again write Vm square by 2 pi alpha to 2 pi sin square omega t equal to 1 minus cos 2 omega t divided by 2 d of omega t. Vm square divided by 4 pi integrate it. You can write 2 pi minus alpha minus cos 2 omega t will be sin 2 omega t divided by 2 sin 2 omega t divided by 2 alpha to 2 pi. Vm square divided by 4 pi. 2 pi minus alpha, this will be minus of sine 2 alpha divided by 2, because sine of 4 pi equal to 0. V O R equal to Vm by 2 root of 2 pi minus alpha plus sine 2 alpha divided by 2 divided by pi. This is the RMS value of output voltage. Now let's find the RMS value of output current. RMS value of output current, IOR. IOR equal to VOR divided by RL. So what is the equation of VOR? VOR is Vm by 2 into RL root of 2 pi minus alpha plus sine 2 alpha divided by 2 divided by pi. So this is the RMS value of output current. Now input power factor. Input power factor. Input power factor will be power delivered to load divided by input VA, means POR divided by PS. POR is VOR into IOR divided by VS into IS. So VOR and IOR equal to IS. Why? Let's see. In this waveform, the I0 is only appear when T1 and D1 is on. So I0 is same as IS. IOR, whatever the IOR is same as IS. जब आपका थायरिस्टर T1 या D1 ऑन होगा, जब कनेक्टेड होगा, तभी आपको आउटपुट में दिखेगा. ओके, सो जैसा भी I आउटपुट करंट होगा वही सेम आपका इनपुट करंट होगा. दैट्स व्हाई IOR इक्वल टू IS. सो इनपुट पावर फैक्टर इज इक्वल टू VOR डिवाइड बाई VS. So what will be the input formula of input power factor? Input power factor VOR, formula of VOR is Vm by 2 pi minus alpha plus sine 2 alpha divided by 2 divided by pi. So and divide by whole divided by VS. So VS is Vm by root 2. So from here this is root 2 into root 2. So this is equal to Vs. So final equation will be input power factor 1 upon root 2, or you can take 2 pi also, root of 2 pi minus alpha plus sine 2 alpha divided by 2. So this is the this is the input power factor of single phase half wave AC voltage controller. Thank you.